So what we have here is we have an example from our assignment today, which was on page 240, which was page 240 that we distributed in the packet. And it is highlighting what we call a difference of squares. And so I have one example pre-done, which was number 1, and that's x squared minus 1. When you're given x squared minus 1, we can identify this immediately as a difference of two squares. And what a square is a perfect square term. Your perfect square terms are going to be your terms that you can actually take a square root, that have a whole number square root. So, for example, 1, 4, 9, 16, 25, 36, and so on. So those are your perfect squares. So basically we have a difference of two perfect squares. In this particular situation, we have x squared. The difference is subtraction. Remember, difference always means subtraction. So we have the subtraction of two squared terms, two perfect squares. So we have x squared and 1. The x squared obviously is x times x, and the 1 is a perfect square because it's 1 times 1. So when we factor a difference of squares, we can actually take a shortcut. So we put our two binomial factors just as we would with any quadratic. If we were doing MF-DARM or factoring with an a value equal to 1, we will end up with the same setup with two binomial factors. So we look at the square roots of each of our perfect squares, which in this case is x and x for the x squared term, and 1 for the 1 squared term. Then our two signs are plus and minus, and we're done. And the question is, why can I factor a difference of squares like this? And the next question is, why does this look like a factored quadratic when there's no center term? Well, basically what's happening is x squared minus 1, I could have written this as x squared plus 0x minus 1, and I could have written it as a trinomial, but there's no reason for me to write that middle term when there's no value to it. It's 0. If I were to factor this out using distribution or FOIL, as some of you've learned, I would do x times x, which would give me x squared. Then I would do x times negative 1, which would give me negative x. And then I would distribute 1 times x, which would give me positive x, and 1 times negative 1, which would give me negative 1. And as you see, because of the distribution that we have a negative x and we have a positive x, in which those two will actually cancel each other out. Therefore, you are left with x squared minus 1, which is what we started with. So that is why we are able to factor and formulate these two binomial factors for a difference of squares, because ultimately we do have a trinomial, but the b value is 0. So it still is a quadratic. So let's do another example, and I'm going to move on to example number 9. I'm going to do number 9. So number 9 on your assignment is 36a squared minus 25b squared. And once again, I need to see if this falls under the category of a difference of squares. First of all, is it a difference? Yes, it is. And are these two perfect squares? And the answer is yes, they are. So first of all, I'm going to figure out what is it that I squared to get 36. What is the square root of my perfect square, 36? And that is actually 6. So this could basically be written as 6 squared a squared. Then I have my subtraction, my difference, and then I look at my next term, which is 25. That is also a perfect square. I could actually write that as 5 squared. So all I've done is taken my original expression and rewritten it with all of my perfect squares actually written with exponential terms. Another way you could write this is you actually could write this as 6a to the second and 5b to the second, or squared. So either one of these is acceptable, and now we're ready to factor our difference of squares. So remember the pattern for the difference of squares. You have your first term, the square root. So I have 6a and 6a, because that is what I'm squaring to get 36a squared is 6a. And then for my second term, I have 5b and 5b, because that is what I squared to get 25b squared. And holding true to our form, since we have no center term, our b value is 0, we have to have a positive and a negative. And this will create the situation where our b value will be 0, and we will end up with a difference of 2 squared terms. So those are 2 examples of doing a difference of squares. Now, as far as adding a little extra in, we're going to move and we're going to do another example. And if you look at your assignment, this example is going to be number 13. So we're looking at number 13 on your assignment. 13 is 5x squared minus 20. So the first thing we're going to do is look at this and see, can we categorize this as a difference of squares? The first question is it a difference? Yes, it is. And do I have 2 perfect squares? And at first glance, I do not have 2 perfect squares. However, there is another thing I can do to possibly find out if I can create a difference of squares. Remember when we talked about factoring earlier on, we always talk about the GCF, or the greatest common factor. So I'm going to look at these 2 terms, 5x squared and 20, and see, do I have a greatest common factor between those 2 terms? And indeed I do. 5 actually goes into and divides evenly into both terms. So I'm going to factor out a 5. That leaves me with x squared minus, and 20 divided by 5 is 4. So now I've factored out the 5. Do I have a difference of squares inside the parentheses? First of all, is it a difference? Yes, it is. And next question is, are these both perfect squares? And the answer is yes. Now that 5 has to stay, but I'm going to rewrite this. 4 is a perfect square. The square root of 4 is 2, so I can write 4 as 2 squared. So now I'm ready to factor my difference of squares. Again, the 5 is still there. You can't forget it. You can't just drop it. It has to stay. I have 5, and then my 2 factors. I have x, and 2, and 2. And in order to ensure that my b value is 0, I need plus 2 and minus 2. So those are ways that we can factor differences of squares. And there are multiple situations that you may run into, and they're not always going to be alike. And you have to kind of gauge what you have before you decide how you're going to approach those problems. Now, one question that I frequently get is, what happens if the constant value is first? So let's look at an example, and this is number 11 on your assignment. And number 11 is 1 minus 4n squared. And most people look at that and say, hey, I can't factor that because the variable is second. There's a constant as the first term in my expression. And this doesn't matter. You're still able to factor it like a difference of squares. The difference of squares does not discriminate. It does not say you have to have 2 sets of variables. It doesn't say the variable has to go first. It just says you have to have a difference of 2 perfect squares, in which case we do here. We have our difference, and then we have 2 perfect squares. So I can rewrite this as 1 squared minus 2 squared n squared. I'm going to write the 4 as its squared term. I could also write it as 1 squared minus the whole quantity 2n squared. Either is correct. Now I'm ready to write my difference of squares. So I have on my difference of squares 1 and 1, so the constant will be the first part of the binomial, and then I have 2n and 2n. So I have plus 2n and minus 2n, and I'm done with my factor. And one thing that it's important to remember is that when you have a difference of squares, you can only have one negative term. So, for example, if I were to have negative x squared minus 25, this would not qualify as a difference of two squares. The reason being is, yes, I have my difference here, but this extra negative is going to cause a problem because in a difference of squares, you have to have one positive value and one negative value. If I tried to look at negative x squared and negative 25 and factor this as a difference of squares, I would not be able to do it. Because if I look at these two, let's follow, I have negative x squared. My first term has to be positive because if you look in all the previous examples, x times x is x squared. 6a times 6a is 36a squared. 1 times 1 is 1. These are all positive values. You cannot get a difference of squares when both values are negative. I cannot factor this. If I were to write this as negative x squared minus 5 squared, and I were to try to factor this in the same manner I did the other one, I would end up with these factors here. I would have to, in order to get negative x squared, I would have to have one negative x and one positive x. And if I tried to follow, I would end up with an issue where I would not be able to cancel my b term. My b term would not be 0. My b value would not be 0 because now I have negative 5x and negative 5x. That would give me negative 10x. If I were to factor this out and go backwards and check my work to see if I got this, I would end up with negative 10 squared minus 10x minus 25. And this is not this. So you have to have one positive value and one negative value. The last thing I'll show you is sometimes you'll have those values created and they might not necessarily be in order. So for example, if I gave you negative 25 plus b squared. Now the first term is negative, but I do have one positive and one negative. So what I actually could do is put the positive term first and put the negative term second. Once I've done that, I now have a difference. I have my subtraction element in the middle. And then I'm able to factor. So I've got b squared minus 5 squared. I've got my two perfect squares. And I'm actually able now to factor my difference of squares. 5, 5, plus, minus. 5b, negative 5b will ensure that not this particular b, but my b value in my quadratic is 0. And I will be left with negative 25 and b squared. And that is difference of squares.